making my first project with C and OpenGL Minecraft clone. So I started with this. I made with learnopengl.com, and I just learned a little bit how to use OpenGL. So yeah, I was able to just make this. So I'm gonna make a cube now, and the way I'm gonna do this is by creating the vertices and then putting them into a OpenGL vertex array. So that's the vertex shader, and this is all the cube vertices. I commented that out. I'm gonna create a cube from scratch now. So I have the code fast forwarded of me typing. I don't actually type this fast. It's about done now, I think. Now it's gonna be a while. So when I run this, it's gonna show a cube. See? One face, two faces, three faces. Yep. Yep, that's a cube. Definitely a cube. The stone texture that I drew myself in Paint. MS Paint. Microsoft. That was kind of generated a chunk, so I'll just code that really quickly. The way I did this is actually just by pressing Ctrl-Z a bunch of times, and that started the recording, then I pressed Ctrl-Shift-Z to redo it all. That's how it goes so fast. And then I also fast forward it 2 times. So this is a chunk now that I made it generate in a weird shape. And yeah, I'm inside the chunk. Alright, so that was pretty easy to do, but it's not very optimized. The chunks are 16 by 16 by 16, and now every vertex stores 8 floating point values, which are 32 bits. This takes up that big number of bytes per chunk, only drawing outside faces. That's why I kept getting segmentation faults. I really need to fix this, because that's a lot of bytes. 196608. It's a huge number. I don't know what that is in kilobytes. I have to divide it by this. Whatever. So I'm just going to create a integer for all 8 of those values, and I'm gonna do it like this, vertex compression, which will show you how it works in just a second after I finish this time lapse of me coding it, of me pressing Ctrl-Shift-Z. So I've just made all the 8 floating points get compressed into one single 32-bit integer. This has dropped memory usage down to 73,728 bytes, with a chunk for the most triangles possible. So yeah, I did it. See, that's the most triangles. So, yep. And the checkerboard pattern is the most faces. And then you can see the formula for that on the screen. Y modulated by 2, XOR, all that, yeah. That's how I make a 3 checkerboard pattern. So this is how the vertex compression works. You can pause the video maybe and look at it. That's special with all the places it is. And, yeah. I was having a hard time getting it to work, because you have to use the GL vertex attrib I pointer, not one without the I, for integers, else it doesn't work for some reason. Yeah, before I figured that out, there were a lot of goofy things that happened. Yeah, I wasn't really sure what was happening here. So yeah, that pretty messed up. And this is gonna be even more messed up now. Look at this. Ooh, it's spiky at the top. Very spiky. sharp. You won't want to fall on that in real life. Yeah, this happened, and that was funny. I don't know what. That's what I was trying to compress the vertices to just be 2 instead of 6 for both triangles in the face. Just 2 vertices, one in the top left, one in the bottom right, and that's what happened. It definitely did not work. And maybe, and if there's a part 2 I might do something like that, but I'm not too worried about that because it already doesn't use that much memory. Yeah, it took me a few tries to get it working for sure. After I got the vertex compression working, I added multiple chunks and Perlin noise for current generation using stbperlin.h. Alright, so, yeah. Now I'm gonna try to get fog to work, and we'll see if I can program this. So, yeah, I just have the view distance, and then the fog. I'll show you how I did that in a second. But it definitely did not work, because I just made a simple mistake. It looks funny, doesn't it? It's neon colored. Yeah, this is fog now. Yeah, successfully got fog to work. It looks really good. Fast forward it a little bit. Yeah, let's do that. So, I'm about to get to the top here. Yep. Just a little bit high. Okay, whatever. Alright, so that's how fog works. You can pause the video. There's that code there. It shows the distance, and then the fog is distance minus 3 divided by 10, and else it's 0. That's how that works. Like this normalized value that we can use in the warp function. So just warp between the values to get the new color with the fog added. Alright, we don't want to float around in spectator mode anymore. Collision is pretty complicated though. I tried a few different ways to get it to work. It took me a really long time. So, just collide with the surface, or we can index into the array of blocks to get a value. But I thought we could just separate the vertical and horizontal movements together, apart, and then just know if there's a block below the player, we have to keep them on top of that. If it's above the player, we need to keep them underneath that block. And then we just take the blocks next to the player and flatten them like this. And that's how that works. So if there's any blocks there, we don't have a block there in our, like 2D collisions. So yeah, I would just like shoot underground. I was getting pretty frustrated with that. But now the collision works pretty good. Alright, caves. So we're gonna add noodle caves.